All right. Whoa. Hello, everybody. All right. Welcome back. How's it going? I hope you're having a wonderful day so far. Welcome back to my stream. Hello, everybody. My name is Michael. Today is Wednesday, March 5th, 2025, and we are continuing on with our learning journey in Python and computer science. I really appreciate you guys joining me here. Hello, one. Hello, all. How's it going? Hey, Wing Hong. Welcome in. It's great to see you again. Hear from you. How's it going? Let's go ahead and get the chat brought up. Let me grab that real quick. Hello all. How's it going? Hey Wing Hong, welcome chat. In. Pop out that chat. Copy web address here. Let's bring this over. Let's go ahead and get the chat brought up. Let me grab that real quick. There we go. And boom, we are running. Pop out that chat. Tim, I don't want to do it. Those LeetCode problems. Hello, Tim. Hello, Wing Hong. How's it going, you guys? I appreciate you guys joining me this evening. Feel free to leave a like on the stream if you'd be so kind. Let's go ahead and jump right on in and get started here. I want to get a at least 15 minutes of. Hello, Tim. Hello, Wing Hong. So let's see what we're gonna do today, guys. Is I want to start. Let's start really getting into some content here. I want to. We got to ramp up our studying. Is there an echo? Oh, there might be. Do I have in the background on accident? Oh, yeah, I do on accident. There we go. Sorry. All right, there we go. It should be fixed. My bad. All right, thank you guys so much for joining me here. So today is going to be kind of a cool day. So in a way that I'm going to try to today kind of marks um, a point in time where I think it's time for us to kick it up a notch. I've gotten into the flow of things so far as we've been, and I've gotten adjusted to it. And so my routine is now set pretty much where at 7 o'clock or around then I come on and stream and I get off and I edit some videos and I go to bed and I repeat. So my lifestyle here is kind of baked in. So it's time to level up. I have set a goal for myself. Now we'll see if will remain true, but I've set a goal for myself that I think I'd like to start applying for maybe some dev positions, junior dev positions, come June 1st. So that gives us basically, a little less than 3 months to really get things into gear here. Now, I don't want to put too much pressure on it because that's been the whole purpose of the stream is to kind of, keep the pressure off of things. But I do want to, at least try. I do think I want to at least give it a shot, throw out some applications, at least try to maybe take an interview and see how it goes and share my experience. I'll never know if I don't try. And we've been doing all this learning up to now, about 7 months worth of learning so far. And, actually probably coming up on, 7 or 8 months worth of learning so far. And so we're wrapping up on coming up on June will be the 1 year mark since I really kind of started grinding away at this with CS50 and other types of resources. So I kind of wanted to give it a shot. Now I am no way saying that I think that I'm like anyway experienced enough to get into one of those positions. I really kind of have an imposter syndrome where I feel like I'm not, but I'll never know if I don't try, and I'll never know where the mark is unless I give it a shot and see where that mark is. Um, so, hey, we'll just give it a go and we'll be along the ride with me here. So, come around June 1st, I'm going to start, throwing out some applications around that time. So, we have a little under 3 months to really kick it into gear, prepare and study, and really take this seriously because it is something that I'm passionate about. And why don't you just try applying now just to get a sneak peek? Well, thank Patrick. That would be. I don't know. Like I said, I have a little bit of an imposter syndrome coming from having a degree in human biology and a minor in chemistry, and then trying to, make my way in here. It's just kind of difficult because I hear that, even people with 4 year degrees in this specialty are having troubles finding work. So, what in my right mind makes me think that I'll be any different not having one of those, degrees, right? So I anyways, I'm thinking that, around June, we'll give it a shot and start throwing out some applications. So we have 3 months to really start grinding away here, kicking it up into gear, and then preparing like a resume and everything. Uh, I mean, we do have a lot of, I think we do need to do a little bit better on our leak code studies. I honestly, I'm just not really that big of a fan. I know a lot of people really, really like the leak code. Uh, it's just, there's something about it that I know it makes me better as a programmer and learning these algorithms, but I would much rather, honestly, have a much more enjoyable time making the projects and actually coding projects than I do just solving those algorithm problems. Now I know that they're essential for building projects at the end of the day, so that's why we kind of want to do them. But I don't really care too much to get into those like super hard questions because at the end of the day, it's not really what I'm passionate about. Um, don't ignore doing your own startup too. In addition, what the heck? We're just ramping it up real fast. What? I actually don't like LeetCode. I don't think it's great at evaluating employees. I don't know. I'm just married to the grind. Yeah, I just don't really like. I think it's very rewarding to solve, but I'm just not really like that interested in it in general. Like it just doesn't really get me going. Like I'm not like, oh, I want to solve some leak code today. No, I'm like, oh, I want to finish my project, and whatnot. But the leak code is what people really like to watch, so that's why I kind of like to force myself to do it. And it really helps to develop some better habits too of pushing ourselves to learn new things. Keeping up with that struggle when you have that fog in your mind. Whenever you have that feeling of fog or whatever, that just shows that you're learning and that it's like your brain is trying to expand its RAM, its capacity, right? So it's trying to wrap its head around it and really trying to get it here. So um, LeetCode is not for programming, but more for gatekeeping because firms get too many applicants. Yeah, that definitely seems true. I'm worried that maybe like someone won't even take me seriously unless I actually know like a couple of decent medium ones and stuff. I do have people they say that work experience is key. Now I don't have work experience in programming per se. I do have it in biotech as a chemist making products physically, not just virtually. But I am kind of working right now, so. I am starting to work with my. I've spoken with my manager and my boss's boss, and they've kind of bought in on a pitch that I've recommended of working alongside with one of the bioinformatics teams that our company has, that work remotely, and then starting to develop my original idea of automating that serum matrix. That was my original passion into starting this whole process. And so I actually met with that bioinformatics team last Friday, and I gave them a pitch, basically like a 5 slide deck pitch about what I do, how I compute this matrix by hand. I had to answer a lot of questions, like 45 minutes straight of just answering questions and doing this pitch about how I come up with these numbers, what it is that the tool actually needs. And then I also really tried my best to convey them that I am also a programmer and I could help them out. And the manager seemed pretty, receptive to that and said, oh, like if you're available to assist us in building this, you sounds like you're a programmer. And I was like, yeah, I am. And I said, I think it would be really, really useful to view these serums or these solutions as objects using object oriented programming, pulling API information from our database, so we can auto generate those volumes and stuff without having to do it by hand. And they seemed receptive, and I'll keep you guys updated with what comes of it. But also when you give corporate people ideas, it can often be taken off without you. So I'm also a little bit skeptical and worried about that as well because I would like to be involved at the end of the day because it would help me learn. At least you have more personality than a CS major, I think. Well, thank you, Tim. I appreciate those kind words. You're really sweet. All right, so like I said, today kind of marks the ramp it up. We got about almost 10 people in here. If you guys could throw a thumbs up on the stream and subscribe if you guys are new, I really really appreciate you guys joining me. And we got to keep the channel, keep it climbing up and getting new people in here and keep growing our community. It's really awesome when we get to meet new friends here. Um, but so I think we're gonna do, let's say, about 15 minutes or 20 minutes. Let's do 20 minutes. 20 minutes of DSA and Python reading, And then today I'm going to launch and start 20 minutes as well. So a total of 40 minutes of reading per stream when we do these streams. Um, yeah, Sticky Steve, exactly. Tim Mahan's still in college. He's still in the grind for the degree here. He goes to I think the University of Toronto. Um, yeah, so we're going to do 15 minutes of DSA and Python reading and note taking, and then we are going to also start today the Fluent Python book. So this image is really blurry, so I'm sorry, but it's just how the PDF is. But I have this PDF included in my Discord, and and I've been really just wanting to start this book and chip away at it. And I've been creating a lot of excuses like, oh, we have a lot of other content going on, but I really feel that there's no reason why I can't split up the readings into two different things. Learning actual deeper level Python and then applying that into data structures would probably actually really help. So I really want to start this. I bought this book. It's been sitting down here in my collection. I bought it for $10 on Facebook Marketplace. Still, I think it goes for like 60. So stole that one, but we are going to dive into that one in the second half of the reading after the 20 minutes. I want to let's bring up a timer. Stopwatch. Timer. Not time machine. No. Let me do clock. Whatever. Let's see. Clock app. Here we go. Okay, so let's set a timer here for 20 minutes. Let me go ahead and I'm going to drag this just over here like such. Let me come here. Can I make this any smaller? It's got to stay that big. Jeez. All right, let's set the timer here. 20 minutes. And how do you get this to start? What's all this? Oh, it's the alarm. Alright, we'll just set a stopwatch here. Okay. Sticky Steve never gets your hopes up when talking with corporate. I'm glad they were receptive. Yeah, me too. I'm glad they were receptive. But yeah, never get your hopes up is a good way to put it. Yeah. Even if corporate lets you shadow one of the bioinformatics people at your company, that'd be huge. So you can see if that work interests you. Yeah, definitely. Like I really am curious to see if they let me get a peek at their team even and like step in and work with I really just want to work with them on this. So I'm trying. Hopefully they'll allow me to. I haven't heard much yet though. You have any intention of learning computer architecture? Yeah, Ray313. After we finish the Harvard CS50X course, I really want to start up some courses regarding computer architecture, hardware, design, operating systems, large-scale software, management, all that kind of stuff really interests me. We're really going to dive deeper here and compound our learning past that surface intermediate level. How are you able to read these books? They always find a way to put me to sleep at times. I really find that you have to read them in spurts. So try to just read about 20 minutes a day. In regard, don't. And after about 20 minutes, I feel like the material can be so dense that it really starts to fade after that point. So try to just limit the reading to about 20 minutes, at least 20-minute stints. So you could do like 20 minutes in the morning and then maybe 20 minutes in the afternoon. But I wouldn't read anything past about half hour in these books, especially if you're taking notes on the side, because your notes will also start to lack in depth and understanding. That's my personal example. Like understanding is after about 30 minutes of reading, I'm really kind of tapped out in terms of my ability. My battery's kind of drained for reception. So take it in stints is really key. All right, let's go ahead and get this going here. Yeah, Ray313, are you interested in computer architecture? Let me know. Hey, Edwards404, welcome in. How's it going? You guys are here. Consider leaving a thumbs up on the stream. We're going to do 20 minutes of reading in DSA and Python, and then we're going to do 20 minutes in reading in our new book, the Fluent Python. Is it second edition? I think it's second edition. So we're going to start up this book today. You guys are here. Leave a comment here in chat if you were here for the start of the book. This is going to be a monumental moment, and we're starting up a new thing. This one's only 339 pages. So honestly, guys, what's quite crazy is we've been reading DSA in Python, and we're on page 437. So we would have already, if we had if we had rode, pause. If we had read, if we had read Fluent Python first instead of DSA and Python, we would have been done with the book by now. So kind of crazy how far you can come if you just start, guys. That's the key, is just starting. I saw this recent TED Talk. I know I'm yapping here. I saw a recent TED Talk of this software engineer, and he was he did startups and was a manager. He said the best employee he ever had was one that was just able to just start the project without having the excuses of I need to research first, I need to learn more first, actually just learning on the fly. So we're going to go ahead and, do you intend to learn Russian or Chinese someday? Whoa, that's like I've never been asked that before. No, I've never thought about that before. Is there a need to learn Russian or Chinese? Why you ask, Edwards? Okay, let's start the timer and let's do 20 minutes in DSA in Python here. So we left off on right, so let's start here. Right? So um we left off on hash codes and compression functions. So if you remember, we're trying to make hash tables, and hash tables bucketize items via certain hash codes. And these hash codes are generated by two implementations or two functions. One is you generate what is it called? Is it generate the hash code itself? The hash function. No, the hash code. Yeah, so you generate a hash code, which can be some large number based on some criteria, whether it be like, it's some algorithm that generates a large number that's unique to that input or that data point. And then a compression function will compress that down to a value within the range of 0 to n minus 1, so you can place in a bucket that is indexable, kind of basically making your own like constant time list where you know where every object is, basically. Now, the whole point of these is we have various algorithms to do these hash code creations that reduce the amount of collisions. So we talked about polynomial hash codes, where these are created by taking the first value gets multiplied by a constant, and then that moved on. The next value gets multiplied by the constant, and then a power of 2. The next value gets multiplied by a constant and a power of 3. Those kind of polynomials. So each number basically has a very large spread in between each code via that exponential factor that's being taken place. We talked about cyclic shift hash codes, which basically used, and now I still don't understand this too much, is the bitwise operators. I like the XOR operator. These operators, I really don't know. I understand them too much. I need to do more research into them. But they basically you generate a hash code and then kind of shift the values like around in like some sort of random format to kind of generate that lack of collision. Basically, you can like cyclically shift the code in a way to generate a randomization, so you can reduce the collision. And then the compression function, obviously. So the compression function, it kind of took me a little bit to wrap my head around, but the second step in creating a hash table ensures that the arbitrary hash values, which could be larger or spread out, are mapped into fixed range that fits right onto the hash table. Returns a value of 0 to n minus 1, where n is the amount of buckets or whatever, right? So the division method, so there's two ways to get it. You can do a division method to find the remainder, right? Hash code divided by the buckets to get basically the remainder. But this would have some collisions where if you have non-prime values, like 100, well, having modulo would allow for multiple values to be, factors of 100 for that hash code. So having non-prime values really um, isn't really effective here. And then we talked about the MAD method, which uses this kind of formula of you take the hash code, multiply it by some constant, add some variable to it, modulo by p, and then modulo by n once again from there. So uh, it mimics a random bucketization where p is some prime number. So you forcibly modulo it by a prime number if n is, non-prime, in the case of instead of using a division method. And then we talked about obviously these collisions and a load factor. Pause. So the load factor, where'd you go? Let me move. I'm going to move this guy over to here like so. There we go. Where's the load factor? Where did it talk about that? So the load factor, the ratio of elements n per bucket, big N, right? So lambda is equal to the number of elements divided by the number of buckets. So if you have more elements per bucket, basically, you're going to have more collisions, right? You're going to have multiple elements per bucket. Whereas if you have a lambda that is less than or closer to 0, you have more buckets than you do elements on average, so you have the room for less collisions. So that's these notes here. Right? These notes are completely accessible on my Discord, so check them out there if you guys are interested. Hello, everybody. Let me get caught up on a couple of chats here. Do we pause the timer on the chat reads? Let's go. Can I window? Can I hover this? Minimize. Bring all to front. Whatever. It's gonna have to be like that, I guess. Because once I click over here, it'll go away. Just wanted to see if he has intentions of doing it. That's all. Yeah. Have you tried Obsidian for markdown note taking? A lot of people have suggested that. I've never tried it though yet. What makes it easier, do you think? Computer smoke. Hey, Smoke Noir, welcome. What do you mean by road, Mr. Timmy? Chill, Tim. English clears for real. Hey, Nat Neil, how's it going? Just curious. And Edward says about learning Chinese and Russian. Based man says, dang, are they really teaching a whole hashing algorithms like the math? Yeah. So 10. Okay, so he gave me an example here. In Python, the bitwise operation can accomplish cyclic shift, truncating results to 32-bit integers. So 10 cyclic shift 2. So if you do two greater than symbols, less than symbols, it adds 2 zeros to it. If you do 11 with 2 less than symbols with a 1, it removes one value, and then if you do with a 1, it adds a value of 0 back. Okay, so is that what it's doing? So the first example, 11 bitwise greater than 1 would remove the ones place index, leaving you with 1, and then you do the opposite bitwise, bitwise, and then that adds the 0 back. The city allows custom theming, note linking, tagging, and a whole plugin ecosystem with a big community. Also, those shifts are in binary, not decimal. It just moves big. It's just moving a binary number over n spaces. The greater than literally means shift to the right position 1 bit, so it strips off the least significant bit. Shift to the right 1 bit. Yeah, so it strips off the tens place in whatever, but that the first bit on the right, and then you would add a 0. So if you do the opposite, it adds a 0 back. Okay. Okay, we got to continue reading here. All right, so those were hash functions, hash codes, polynomial, cyclic shift, hash codes, compression functions, division method, open addressing. Okay, I think we're here. Linear probing and its variants. A simple method for collision handling with open addressing is linear probing. Okay. So what is open addressing again? Okay, so let's see here. Let's bring back up the. So open addressing. Um, right. The separate chaining rule has many niche properties, such as affording simple implementations of map operations, but it nevertheless has one slight disadvantage. It requires the use of an auxiliary data structure, a list, to hold items with colliding keys. If space is at a premium, for example, if we were writing a program for small handheld devices, then we can use the alternative approach of always storing each item directly in a table slot. This approach saves space because no auxiliary structures are employed, but it requires a bit more complexity to deal with collisions. There are several variants of this approach, collectively referred to as open addressing schemes, which we discuss next. Open addressing requires that the load factor is always at most 1, and that items are stored directly in a cell of the bucket array itself, in the cells of the bucket array itself. So what is open addressing in simple terms? Open addressing is the way to handle collisions in a hash table. Instead of storing multiple values of this in the same bucket like chaining does, open addressing open addressing finds another empty slot in the table to store the new value. When inserting a key, if the intended slot is already occupied, open addressing searches for the next available spot using a probing technique like linear probing, quadratic, or double hashing. When searching, it follows the same probing sequence to either find the key or confirm it's not in the table. It's efficient when the table isn't too full but can slow down as it fills up. Okay, so open addressing. A way to handle collisions in a hash table where instead of storing multiple values in the same bucket, like chaining, values instead find another empty bucket if the primary or the initial one is already occupied. Okay, so let's go ahead and throw this in and see if it likes it. Yep, that's a solid definition. You might want to tweak find an empty bucket to find an empty bucket. Okay. Otherwise, it's on point. Okay, sweet. So it just basically overrides that. If there is an item already at that bucket, then we're going to go ahead and override the current hash code and just find another bucket. Okay. Linear probing and its variants. Oops. A simple method for collision handling with open addressing is linear probing. Okay, so number 1, linear probing. A simple method is linear probing. With this approach, if we try to insert an item with a key value tuple into a bucket of array at index j that is already occupied, just like in the open addressing example, where j is already occupied where j is equal to h of h of k, where j is equal to h of k, hash of k. Okay, so j is okay. So the hash code of this, then we array. Then the next try would be j plus one modulo n. Okay. So if you go to a, if you are trying to, if you give it, if an item object is given a hash code via its key, right, via this hash of a key, and the hash code is j, that's what this is saying here, right? You have a hash function which is working on some key, and then it's giving you out some hash code, right? If using linear probing and open addressing, if that hash code correlates to an already occupied bucket, then we recompute a hash code of we try the next no we try the next bucket of j plus one modulo the current number of buckets, which is big N, right? So if array, so if that is also occupied, then we keep going and so on and so on until we find an empty bucket that can accept a new item. Once this bucket is located, we simply insert the item there. Of course, this collision resolution strategy requires that we change the implementation when searching for an existing key. The first step of all, of course, this collision resolution strategy requires that we change the implementation when searching for an existing key. The first of all, get item, set item, or delete item operations. In particular, to attempting to locate an item with key equal to k, we must examine consecutive slots starting from array at hash k until we either find an item that with that key or we find an empty bucket. Okay, right? So you continually go down this same search method, right, until you either find the item or find an empty bucket, which means that item doesn't exist because it would have been in that bucket. Syndicus, hey dude, how's it going? Thank you for joining me here. If you guys are here, consider leaving a thumbs up on the stream. I really, really appreciate you guys joining me here. You guys are awesome. We got 5 or so minutes of reading left here. Maybe we'll finish at the 25 mark, but we're almost done with reading in DSA here. Okay, so linear probing. Where you say if trying to insert an item with a hash code of j equals to hash of sub k, right? Of j, where j equals that. If trying to insert an item with a hash code of j, and that bucket is already occupied, then we try to insert the value or the item at array big A index j plus 1 right, modulo big N, right? So if trying to insert an item with a hash code of j, where j is equal to hash of k, then that bucket is already occupied, then we try to insert the item at array A, j plus 1 modulo n. Right. plus 1 modulo n. Um, if that is also occupied, continue increasing the constant, the numerical addition for each attempt. All right, let's go ahead and do that. Let's put that in the almighty orb, see what it says. All right, come on. What you got? What you got? What you got? Oh, it's shy on me here. It's shy here. Thumbs up. When is your birthday? It's my nice, dude. Nice, Syndicus. All right, what's going on here? Come on. What is going on? Is collisions resolution open addressing hash table? A few key points to remember. If a collision occurs at index j, the next probe is at j plus 1 modulo n. This process continues until empty slot is found. Okay, it likes my definition. Okay, if trying to insert an item with a hash code of j, where j is equal to the hash of k, an item, key value, with a hash code of j, and that bucket is already occupied, then we try to insert the item at array index j plus 1 modulo n. If that is also occupied, continue increasing the numerical addition for each attempt. Okay, cool. So, new element will be inserted with key equals 15, okay? Key equals 15. Oh, it's here. Probe must probe 4 times before finding an empty slot. Boom, 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 boom. Okay, there. Okay, so it just basically keeps going down the line. Insertion into a hash table with integer keys using linear probing. The hash function is hash k equals k modulo 11, which values associated with keys are not shown. Okay. So key modulo 11 would give index 4. So we're trying to place at index 4 for this hash code, but that doesn't work because if something's there, so we're trying to place it at 5, 6, 7, now 8. Boom, empty place. When you hit 1.6k subs, I'm pouring a glass of wine. That sounds good. Awesome, Tim. Well, what are we at right now? If you guys are here, not subbed to the channel, make sure you guys throw a sub on it. It really helps to keep YouTube promoting our content. Like Syndicus said, he's saying we're getting suggested content by him. So, or YouTube is suggesting us to him. So let's go ahead and check here what we're at. Still at 1544. We've been stuck at that number for a few days now. It's all good. It's about the learning here. Okay. Next. Let's what are we at here? We're at 22 minutes. Let's go until 25. To implement a deletion, we cannot simply remove the found item from its slot in the array. For example, after the insertion of key 15 portrayed in figure 10.7, if the item with key 37 were trivially deleted, right, if the item were trivially deleted, right, it would search this one initially, realize that this is gone, and then think that that key is not there, but it actually exists in this 8 index. So that's what it's trying to say here. So For example, after the insertion of key 15 portrayed in figure 10.7, if the item with key 37 were trivially deleted, a subsequent search for 15 would fail because that search would start probing at index 4, then index 5, and index 6, at which it would find an empty cell because 37 was deleted at index 6. And we're trying to locate the item here because its original hash code corresponds to here. A typical way to get around this is difficult. This difficulty is to replace a delete item with a special available marker object. With this special marker possibly occupying spaces in our hash table, we modify our search algorithm so that the search for a key k will skip over cells containing the available marker and continue probing until reaching the desired item or empty bucket. Okay, so you basically, if you want to remove the item, you don't remove it by popping it out, or like, you just put a flag on it saying available slot so you can then override if need be. So you can keep the same order. Empty bucket return. Additionally, our algorithm for Dunder set item should remember an available cell encountered during the search for K. Since this is a valid place to put a new item KV, it's if no existing item is found. Although using an open addressing scheme can save space, linear probing suffers from an additional disadvantage. It tends to cluster the items of the map onto contiguous runs, which may even overlap, particularly if more than half of the cells in the hash table are occupied. Such contiguous runs are occupied hash cells cause searches to slow down considerably. Another open addressing strategy known as quadratic probing. Okay, here we go. Quadratic probing iteratively tries the buckets of A at hashcode K plus function of I modulo N for I equals 0, 1, 2, where function of I equals to I squared. Okay, so we'll copy this. We'll say if trying to insert an item KV with a hash code of J where J is equal to hash of K, and that bucket is already occupied, then we try to insert the item at this here. I'll copy it, but I'll just edit here. A index J plus F of I. For 1, I'll say 1 squared, right? If that bucket is already occupied, continue increasing the numerical addition being squared for each probe attempt. All right, I like that. Let's go ahead and copy that one in and see what it says here. Maybe it'll work here now. Come on, come on. The explanation is mostly correct, but could be significantly refined for clarity and completeness. Here's a more polished version. Quadratic probing. If trying to insert an item KV with a hash code of J, where J is equal to some hash function of K, the key, and the bucket is already occupied, we probe using a quadratic function where the next bucket, probe using a quadratic function. The next bucket is checked at array index j+1 squared modulo n. If that is also occupied, we continue probing using, and so on. Okay, so, okay, yeah, that sounds good. So we'll put here, we'll say pitfalls, right, or cons. We'll say cons, right? Cons of linear probing are right. It tends to cluster items. Contiguous clustering. Right? Contiguous clustering, which is due to linear probing, checking index values of checking contiguous buckets for probing on occupied unoccupied spaces. Items tend to cluster cluster in a line. So let's take this and see what it says for that disadvantage. Contiguous clustering, since linear probing searches sequentially through adjacent buckets. Okay, that's a better way of putting it. Since linear probing searches sequentially through adjacent buckets, items tend to form clusters. Which increase the likelihood of collisions and so down, increasing the likelihood of collisions and slows down algos. Okay. Why W's were written weird. Some sort of acronym or whatever it is. W, everything starts with W there. Hey dude, how's it going? If you guys are here, make sure to follow along and subscribe here. I appreciate you guys joining me. We're coming up on 1,600 subscribers. I also just put up a video today of the recent Python crash course Try It Yourself walkthrough. I completed and read that book, over almost 4 or 5 months ago at this point. But I'm just going back through and uploading the solutions to the Try It Yourself problems for other beginners out there that might find those useful, and having me break them down in my own words in terms of learning that way. So you guys can check that out. It's live on the channel right now. I'm going to try my best to actually do daily uploads on the channel. I'm going to try to commit to that a part of my studying, right? So like I said at the beginning of the stream, on June 1st, we're going to try to commit to actually start applying to junior dev positions and getting our foot in the door potentially. So we're giving ourselves until June 1st to really grind away here and study. That kind of marks the 1 year mark of our journey here so far. And so that being said, is we're really grinding away here. And what was I even talking about? My train of thought just completely went away. What was I even talking about? I forgot. All right. Anywho. Okay, let's just finish this page and then we'll be done with the reading in this book so far, and then we'll move on to the next one. Okay, right? So until finding an empty bucket. As with linear probing, the quadratic probing strategy complicates the removal operation, but it does avoid the kinds of clustering patterns that occurs with linear probing. Nevertheless, it creates its own kind of clustering called secondary clustering, where the set of filled areas cells still has a uniform pattern, even if we assume that the original hash codes are distributed uniformly. When the number of buckets is prime and the bucket array is less than half full, the quadratic probing strategy is guaranteed to find an empty slot. However, this guarantee is not valid once the table becomes at least half full or if the number of buckets is not chosen as a prime number. We explore the cause of this type of clustering in exercise C 10.36. An open addressing strategy that does not cause clustering of the kinds produced by linear probing and the kinds by quadratic probing is the double hashing strategy. Okay, number three, double hashing. In this approach, we choose a secondary hash function h prime, and if h maps some key to a bucket a index hash of k, then that is already occupied. Then we iteratively try the buckets at a index hash k plus f of I mod n next, 4 all the way up to 1, 2, I equals 1, 2, and 3. So quadratic probing. Where f of index I is equal to I times h prime index k. In this scheme, the secondary hash function is not allowed to evaluate to 0, as a common choice is h prime is equal to q minus k mod q for some prime number q that is less than the number of buckets. Also, n, the number of buckets, should be prime. Okay, that was a lot of information here. So we'll come back and hit double hashing tomorrow to solidify that one here. But let's go ahead and shift our gears here, you guys, to starting our notes in start reading Fluent Python. So I have a book down here, Fluent Python, that we're going to get into. Let me see here. 323. What page is this? 883. This has 339 pages. Let me see here. Let me move this out the way. Let me see. I haven't taken these down in a while. Okay, so there's like a page difference. I want to make sure we have the right copy here. Meta classes in the real world. Weak references. Functional parameters as references. Does it have a glossary? Let's go back up here. Here we go. So the Python data model, Python card deck, special methods, emulating, collection APIs, an array of sequences here. Page 21. This is page 39. So let's make sure. As you may have noticed, several of the operations mentioned Yeah, it looks the same. Looks the same. Alright, let's get started here. How about, yeah? Let's get this show on the road. Currently reading Fluent Python right now. Put that up there. Cool. Alright, let's dive into some Fluent Python. How about, yeah? Cool. Let's keep the good times rolling here. Let's go. Let me go ahead and open up a new repo. Hey Nemcos, how's it going? Appreciate you for joining me here. Let's go repos, new folder, Fluent Python. All right. And then let's go ahead and here, let's code this guy up. All right, we'll save this. Exit here. Put this up. Boom, Fluent Python. Let's get started here. Yeah, we're going to start new Fluent Python today. I want to get into learning more about Python Advanced. I think it really helped us to continue on here, and I want to dive deeper. We've been putting this one off for too long now. It's time for us to really start. All right, part 1, prologue, chapter 1, the Python data model. Okay, so we have a timer going here. I've been doing reading for 40 minutes. We'll probably do up until the top of the hour, and then we'll move on. Okay. Chapter 1. Okay. Python data model. Okay, there we go. Chapter 1 notes.md. Okay. Chapter 1, the Python data model. Cool. All right, here we go, guys. Get some thumbs up in chat right now if you guys are excited for the new book starting today. This is a great milestone, so this is a great time to, start something new if you're wanting to get like a deeper learning. I'm going to go ahead and throw in chat here that we're starting the Fluent Python right now. We are starting the book Fluent Python today in stream. Join to read chapter 1 with me. All right, let's keep going here. Okay, chapter 1, Fluent Python. One of the best qualities of Python is consistency. After working with Python for a while, you are able to start making informed, correct guesses about features that are new to you. However, if you learn another object-oriented language before Python, you may find it strange to use length collection instead of collection.length. This apparent oddity is the tip of the iceberg that, when properly understood, is the key to everything we call Pythonic. Perfect. The iceberg is called the Python data model. Right? And it describes the API that you can use to make your own objects play well with the most idiomatic language features. You can think of the data model as a description of Python as a framework. It formalizes the interface of the building blocks of the language itself, such as sequences, iterators, functions, Uh, what the word? Correctness, correctness, crowdness, co-routedness. What? What is that word? Co-routiness. I've never heard of that word before. All right. Uh, Crowdiness, classes, context managers, and so on. Co-routines, routines, co-routines, co-rowdiness, rowdiness. What? Oh, my English is not too good right now. All right. You would think I'm a native English, not an English native English speaker, right? Okay. As a framework, when using a framework, we spend a lot of time coding methods that are called by the framework. The same happens when we leverage the Python data model. The Python interpreter invokes special methods to perform basic object or operations, often triggered by special syntax. The special method names are always written with the leading and trailing double underscores. Get item, for example, the syntax object index key is supported by the Dunder get special method. In order to evaluate my collection index key, the interpreter calls my collection dot get Dunder get item key. The special method names allow your objects to implement, support, and interact with fundamental language constructs such as collections, attribute access, iteration, including asynchronous iteration for using async for, operator overloading, function and method invocation, string representation and formatting, asynchronous programming using await, object creation and destruction, manage contexts, including asynchronous context managers with async. Magic and Dunder. The term magic method is a slang for a special method, but how do we talk about how do we talk about a specific method like Dunder get item? I learned to say Dunder get item from the author and teacher Steve Holden. Okay, so just some little notes here. What's new in this chapter? This chapter had a few changes from the first edition because it's an introduction to the Python data model, which is quite stable. The most significant changes are special methods supporting asynchronous programming and other new features. Ooh, what the heck? Um, Special methods supporting asynchronous programming of the new special features added to the tables and overview special methods. Figure 1-2 supporting the use of the special method in quote collections API, including collections.abc.collection, abstract based class introduced in Python 3.6. Also here and throughout this second edition, I've adopted the f-string syntax introduced in Python 3.6, which is more readable and convenient than the older string formatting notations, the string.format method, and the modulo operator, percent operator. The most common reason to use my string.format is to build a template with my format at runtime. That is a real need, but doesn't happen very often. Got the hiccups. Yeah. All right. So, what is the Python data model? The Python data model is a framework that defines how objects behave in Python. It consists of a set of special methods, also called Dunder or magic methods, that allow objects to integrate seamlessly with Python's built-in features like iteration, object operator overloading, and attribute access, right? Perfect. So that's a great definition. So this is just telling you that Python it gives you the framework to create objects using object-oriented programming like we've talked about before. So here we go. We're going to get an example here called a Pythonic card deck, right? So let's do here Did you intentionally add an extra hashtag at the end of your markdown heading? Do you only need one hashtag? Oh, okay. Is there a smaller heading like H1? Aha, there is. Cool. Okay, H2 we'll say is a Pythonic card deck. Oh, two hashtags at H2, 3 is 3, 4. Okay. Cool. Okay, a Pythonic card deck. What's the bold? Is it 2 ampersands? Yeah. Cool. Okay, here we go. Example 1.1-1 is very simple, but demonstrates the power of implementing two special methods, get item and dunder length. Do you guys suggest that we try to do Obsidian? Like, how would we have to install it or something? Like, being that we're starting the notes from scratch, because I'm gonna try to write this entire code here. I want to include everything. So let's go. Actually, let's go here and let's open up a file called. We'll say card deck.py. Obsidian is great, but also dangerous. How so, AJ? Appreciate you for your feedback. Okay, so let's go import collections. We're going to have a card is equal to collections dot named tuple, quote, card, with a list options of, quote, rank and, quote, suit. Okay, so we're creating a named tuple with a key value of card and a values of rank suit inside of a list for its second options. So what does the name tuple do? Returns a new subclass of tuple with name fields. Okay. So we have class French deck, right? Ranks is equal to a list comprehension where we're going to stir every value of n for n in the range of 2 to 10, inclusive of 10. We're going to add that to a list of J, Queen, King, Ace. Right? We have suits is equal to, quote, spades, diamonds, clubs, hearts. And we'll call that split here. Interesting. It's kind of cool to see how they're doing this. They're just doing a split method on the string, so you don't have to like do each suit itself. You can just get suits, which splits them into a variable containing 4 strings. Okay. Def underscore init, initialize, on self, right? So self dot underscore card. So this is a non-public, a private variable via the underscore prefix. Where we're going to take a list comprehension and make a card that has a rank and a suit. For every suit, in self.suits and for rank in self.ranks. So my question is do I have this set up right? Right. Can lead you down massive rabbit hole for quote productivity, but it's my favorite note platform, and all the quote productivity stuff probably we won't use. I mean, you are using VS Code for notes right now. Yeah. It also has a publication service you can buy if you want a website that works like Obsidian to share notes, and there's a plugin for working with Git. I've definitely fell into the productivity rabbit hole before. So it just gives you more tools, and more tools doesn't always equal more efficiency, right? Is my stream lagging for you guys? The connection is kind of chopping out here. Let me know if it's laggy. Well, I'll check it on my phone here. How about? I'll check it on my phone. How about? Let's see. Let me make sure that we're still a good live here. Let me know if it's laggy. Well, I'll check it on my phone here. How about? Yeah, it's really choppy. Okay, it should be back now. Looks like it's stabilizing. Okay. Okay. Then we have def, Dunder length, on self, right? Which will we can return the length of self.cards. So cards self._cards is here, and it's a list, so you take the length of that value to return. Okay. Okay, so we're creating a rank. So we're creating a value of 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 10 different values plus J, queen, king, and ace, right? Then we have 4 suits, and we're creating a card for every suit and for every rank. So you'll have a value of 2 for a spade and right, and a value of 2 for a diamond, a value 2 for a club, value 2 for a heart, value of 3, value 4, value all the way until jack spade, jack diamond, jack club, jack queen, jack heart, jack hearts, king, ace, so on and so forth. Cool. I see what's going on. Okay. I just not what is this what is this part here? Then we have def done underscore get item self position return self dot underscore cards position. Okay, so the get item is just to get the index value. Okay, value at that index. Okay. Yeah, it was lagging a little bit. My connection was spotting out, but it should be good now. We're back up to 16, 17 kbps, so I think we're okay. Let me know if it's not that great anymore. Hopefully it's okay. Make sure to thumbs up and subscribe if you guys are new here. I really appreciate you guys joining me and hanging out with me here day in and day out. We're reading Fluent Python on the stream live right now and taking notes. You guys can access this PDF in the Discord under the Fluent Python tab here for to access this book and EPUB version. Okay, so let's say here we're going to make some notes here, right? Um, a list of all ranks in a deck of cards, right? Um, so it'd be 2 through 10 and J for Jack, Q for Queen, K for King, and A for Ace, totaling 2, 3, 4, 5, 6, 10, 14. 10, 11, 12, 13. Are there 13 cards per 13 cards, 13 ranks? Right? Is there 13 numbers? 2 through 10, so that's 9, 11, 12, 13, 14. Oh, no, is this 8? 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, Jack, Queen, King, Ace. Wait, am I tripping? 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack, Queen, King, Ace. 13. This is 10, 11, 12, 13. Yeah, 13 ranks. It's like I haven't even... Man, come on, Mike. You've played with cards before. Okay, so now we have suits. So, does dot split return a list when used on a multi-word string? Yes, dot split returns a list when used on a multi-word string by default. Okay. So, dot split will split the string on the spaces and save the values in values words or suits words/suits inside a list. Suits. Right? Cool. So the dot split will split the string on the space and save the values words and suits/suits in between inside the list, a list called suits. Okay. When we initialize, so this is the special method. What does init stand for? Initialize? Yeah. Use used to assign attributes objects on creation. Instantiation. Okay. So what's going on here specifically, right? We are we're creating a card object for every suit, a card tuple for every suit, and self.suits information. Okay. So this is creating a card tuple where for every suit and every rank in the French deck class. Okay. And then this guy here, it's putting a list of card tuples. So be like example would be rank would be 2 diamonds, or the king of hearts. Okay, so then here, return the length of the list of cards in the French deck via the self._cards non-public instance variable. And then in this one, returning the item found, the card found at the given index position from from the deck of cards, from the list of cards in the self._cards list instance variable. Hey Charlie, how's it going? I appreciate you for joining me here. We are reading and starting the Fluent Python book today. I've had this sitting down here back here on my little library shelf for a few weeks now, and it's finally time we cracked it open and gave it a go here. So we are doing this here. Okay, so this is going to be define a class called that is a named tuple called card that has a rank and suit. Let's see what this line is really doing here. Oh, you're on the right track. You need to import collections first. Yeah. What does this line do? The line card equals collections not name tuple card rank suit does the following: creates a name tuple class, right, called card using collections.name tuple. A name tuple is a subclass of a regular tuple where each element can be accessed by a name instead of just an index. Okay. A named tuple is one where um, where each element can be accessed by a name instead of just an index. Okay, so let's take this. How does this look? This looks great. Cool. All right, we've broken that down. Let's go ahead and move on here. The first thing to note is the use of collections.nameTuple to construct a simple class to represent individual cards, right? Since Python 2.6, we can use nameTuple to build classes of objects that are just bundles of attributes with no custom methods, like a database record. In the example, we use it to provide a nice representation for the cards in the deck as shown in the console session. So beer card is equal to card 7 of diamonds, call beard card would give you card rank equals 7, suit equals diamonds. Okay. Okay, so the first parameter is the name of this class called card, and then the second one is the list of all the attributes that it has, and then it can have key value pairs for these basically. Okay, so you're pretty much making like a constant access dictionary object here. Hey, how's it going? M plays too. I appreciate you for joining me here and following along to the channel. And if you could, throw a thumbs up for joining me here. I appreciate you so much. My setup is honestly pretty simple. It's just a basic one monitor and a MacBook Pro. So I have a MacBook Pro M3 Pro, not the base M3 Pro, not the base M3, but the M3 Pro, one spec higher for the cores and graphics cores, as well as 36 GB upgrade for the RAM. Um, I have the 14-inch version. I have it just plugged into a dock here with just a single monitor here. That's what I code on. It's just a single 27-inch monitor if it's not my laptop. So nothing too crazy. It's pretty analog. I use my laptop webcam as the webcam here, so it's very analog and very lo-fi-ish, but we keep it that way to, I think it's important, we don't, if we're so focused on being fancy in terms of being a streamer, then we're not really focused on the content and learning. So I think by having it be more bare bones, it kind of makes the environment more about the learning here, which I think a lot of people also respect as well. Yeah, I went to college. For those that are new, I'm 26 years old. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company. I've been teaching myself how to code for about 7, 8 months now, and it's been quite the journey so far. We're currently diving into some more advanced, like intermediate and advanced topics, into data structures and algorithms, Fluent Python here, starting that book actually today. So this is a great opportunity to join along with me for a nice, starting point here. If you're looking to get into starting a book here with me, I read books here live on stream just as we're doing now. I take notes and share those with you guys. We're doing courses, and so right now we're doing Harvard CS50X. We're on week 9. We're about to finish week 9, and which is and then we have week 10, which is the last week of the course, and then we're going to start doing some math courses and building more projects and really grinding away here. For those that are also new, I set a kind of a hard date for myself. For June 1st, 2025 is the day that I'm going to start applying for, some junior dev positions. And, it's going to be an interesting experience. I'm going to try to make the transition and try to at least get my foot in the door and try to take an interview and see what it's like, at least, if I can even get one. But on June 1st, I think is the day that we're going to try to actually start throwing out some resumes for potentially, seeing if it were, accepted into tech or whatnot, if all this hard work, can pay off or whatnot. And You know, at the end of the day, if we don't find a job, it's not really about that too. At the end of the day, it is about learning and becoming better as a person, as a student. You know, by learning this stuff in my free time, I've just become smarter as an individual in my ways of thinking, my ways of problem solving issues within my own life. So the the education is not just, you know, one is unidirectional, it's multi-directional. Whew. Sheesh. All right. But the point of this example is the French deck class. It's short, but it packs a punch. First, like any standard Python collection, jeez, what the heck? That sneeze threw me up. Like I can't even like see. It's like all foggy. First, like any standard Python collection, a deck responds to the length function by returning the number of cards in it, 52. So let's go ahead, right? We can put this to test. Let's go ahead and call. Let's go ahead and make deck equal to French deck and call length of the deck. Right, and then we'll print this. Oh, no. I thought I gave it Dunder length. Oh. There we go. 52. We got the class set up. Nice. Carlos says, bro, I've been stuck in the book, still on chapter 11, just that I've had to catch up with other courses. Still plan on finishing it, though. No problem, dude. Just take it at your own pace. Really try to remove the pressure off yourself, Carlos. I really find that in my perspective and point of view that by removing the pressure and, you know, that guilt of not reading, or at least trying your best to remove that. Now, it does help to have a little bit of it to, you know, get yourself moving, but to remove a lot of it, like if you really can't get to it at the end of the day, don't sweat it because you know that'll just cause burnout and you know it's not a good mentality to have and then you'll rush through it you won't be as you know receptive to the material. Yeah, yeah, pressure really breaks us down. Really just remove the pressure and you know it's okay, you know, don't try to race through it, really take your time through it. And you know, chapter 11 is chapter 11 on classes. That can be a tough chapter. Right. So for those that are new, he's talking about the Python Crash Course book. I provide a bunch of books in my Discord, the ones that we're reading live on stream from the Fluent Python that we're doing now, and data structures and algorithms to the Python Crash Course that we've already read. I have those in the Discord completely for free for you guys to also read if you're interested. And Carlos has been reading that one right now. Being an English native person it maybe is easier, right? In what context are you referring to? In programming? Thanks for coming in, Orsted. I appreciate you for joining me and following along here. Thanks so much for being here. You're awesome. All right. Okay. Reading specific cards from the deck say the first or last should be as easy as deck 0 or deck -1. This is where the get item method provides. So we'll say print deck -1. Right? So this should give us Ace of Hearts is our last card in the deck. And same here. Woo! All right, we got that right. Should we create a method to pick a random card? No need. Python already has a function to get a random item from a sequence, random.choice. We can use it on we can use it on a deck instance. Okay, so we'll go like this. From random import choice. We'll do call a choice on the deck itself. do hearts. So we need to call a print on this as well. Choice doesn't print, it just returns. There we go. 5 of hearts got randomly chosen. Nice. We've just seen 2 advantages of using the special methods to leverage the Python data model. Users of the classes don't have to memorize arbitrary methods for standard operations, how to get the number of items, is it size, length, or what? Is it easier to benefit from rich Python and standard library? It's easier to benefit from the rich Python standard library than and avoid reinventing the wheel like a random choice function. But it gets better. Ooh, whoops. Because our Dunder get item delegates to the list operator of self.cards, our deck automatically supports slicing. Here's how we can look at the top 3 cards in the brand new deck and then pick just the aces by starting at index 12 and skipping 13 cards at a time. Okay, so you go 12 to the end. Okay, so in this example, he goes deck, so print deck, right, index. We're going to take a slice of this deck. We're going to start at index 12. We're going to go to the end, right, by saying 12 to the end, and then have a skip of 13 cards. So this space in between, you might miss it, but it's technically like a blank in between this, basically saying 12 to the end, right? So now if we do that, we get this here. Card rank A, spades, card rank A, diamonds, card rank A, clubs, card rank A, hearts, right? So that gives us the all the aces basically, right? The ace, which is the 12th card, and the which is the 12 multiples or factors, and then skip every 13 to get those 12 factors, right? Those 4 factors. Okay. Just by implementing the get item special method, our deck is also iterable. Okay, so let's go here. Let's do so we'll go here and call special methods, right? We'll do a definition for those. We have some examples. One of the Dunder get item, and we have 2 for the Dunder length, right? You guys might be like, oh, why are you taking such detailed notes, or why are you going so hard in taking notes? Does it really help? Yes, honestly, you guys, it really does help in terms of retaining this information. I had that question just like a lot of you guys might have or had back in the day, is how am I going to remember all of this stuff, all of these functions, all of these variables, all of this info? How am I going to remember it all? And really, I can really attest that up to this point, just actually writing it all down, whether it be actually word letter by letter, actually typing, not just copying and pasting it from the book, but typing it out, even if it's the same verbiage, has really just helped to solidify this just over and over and over again. Right? Okay, so there's that. So you can do slicing, iterable. Also means it's iterable, right? Iterated in reverse. So 4 card in deck print card. 4 card in deck reverse print card. Yep, reversed. Ellipses in doc strings. In doc tests. Whenever possible, the Python console listing in this book were extracted from doc tests to ensure accuracy. When the output was too long, the elided part is marked by an ellipses, like in the last line of the preceding code. In such cases, we use the hashtag doctest ellipses directive to make the doctest pass. If you're trying these examples in the interactive console, you may omit the doctest directives altogether. Okay. Oh, we got our typical spam chatter on Twitch. If you guys aren't aware, I'm also streaming on Twitch. If you'd rather watch on there, appreciate you guys for joining me here. Will you learn any other programming language? Yeah, Charlie, we've been learning C, we've been learning JavaScript, we've been learning HTML, CSS. Those are more like just frameworks, though, rather. And so we've been kind of compounding this even further via the Harvard CS50X course. Orsted says, I mean, I'm a Spanish speaking person. When I started to get interested in programming, I realized that I need to polish my English a little more. Yeah, I do feel for you non-English native speakers because it would be fairly challenging to, transition into this realm via if it's all English. I had that thought before. Let me know your guys' experience with that. Iteration is often implicit if a collection has no Dunder contains method. The in operator does a sequential scan. Iteration is often implicit if a collection has no Dunder contains method. And the in operator does a sequential scan. Case in point, in works with our French deck because it is iterable. Okay, so let's do Dunder length iteration versus Dunder contains. Both length and contains are special methods in Python, but they serve different purposes. The length method is used to define the behavior. The length function is called when Python evaluates length object where the object instance is a class. It should return the number of objects or the size of the object. The contains method defines the behavior of the in operator. When you check if an object is in an object, element is in an object like x in object, Python calls the contains method. This method is used to determine if an item exists, true or false. So then what about this? You're absolutely right. If a class is iterable, contains the iter method, Python can use the in operator to check for the membership even if the class does not contains method. When you use the in operator on an iterable, Python will fall back on iterating through the collection performing a sequential scan. Okay, so basically what this is going to do is output's true. Okay. So 3. The Dunder contains, right? So let's put over here. Let's do so returns the length or size about getting the size object, whereas contains about getting is used to define the behavior. Used to define the behavior of the length function, right? We'll say the keyword is supported by the length method via a default scan sequential scan if the Dunder contains method is absent, right? Seems like you're exploring the behavior of the length in relation to contains. Let's clarify. The length defines behavior of the length function as you correctly mentioned. It determines the length of the function when called out. However, length does not directly influence behavior of the in operator. The in operator checks for membership in an object. If the contains method is defined, Python uses it for membership tests. If the contains is not defined, Python will fall back and iterating through. Okay, so we'll say control X here. We'll put this on the contains rather. Keyword is okay. Keyword is supported by the length. The Dunder contains method. Yeah. Oh no, not in. It's not is, it's in. Keyword in is supported by the contains method. We'll say right, default to sequential scan if the contains method is absent. For loop. Okay. I like that better. Your statement is almost there. The contains method defines the behavior of the in operator checking membership in a collection. Right. Defines the behavior of the in operator for checking membership of in a collection, right? When you use the in keyword, Python internally calls the Dunder contains method to determine the element exists. Defaults to a sequential scan via for loop. If the contains method is absent, but only if the collection iterable and the collection is iterable. Okay. So get item. What determines iterability? What special method determines iterability? Iter. If the class implements an iter method, it means the instance of the class are iterable. So by default, that list had an iter method. Okay. How about sorting? A common system for ranking cards is by rank, with aces being highest, then by suit in the order of spades, highest, then hearts, diamonds, and clubs lowest. Here's a function that ranks cards by a rule, returning 0 for 2 of clubs and 51 for the ace of spades. So suit values, dict, spades is 3, hearts is 2, diamonds is 1, clubs is 0. Spades high on card, rank value. Okay, so here we'll call a method here called def spades high card rank value is equal to French deck dot ranks dot index card dot rank, return rank value times the length of suit values plus suit values index card dot suit. Suit values. Suit values. Where's he getting suit values from? Oh, here. There we go. Okay, so spades high takes this dictionary, right, where spades is 3, hearts is 2, diamonds is 1, clubs is 0. We call French deck dot ranks to get access to all the ranks, so 0, 2 all the way up to ace. We index card dot rank, so the current card's rank. We get the return back so we're providing a card here. The card will have a rank associated with it via this, right? So we will go ahead if it's clubs, no, if it's like, let's say 2, okay, we get the index of 2 card rank. What does dot index do? They probably use to find the index of the first occurrence of the specified value. It raises the value if the value is not found. Okay. So find the first object at this index within the ranks list. That's the rank value. Return the ranked value time the length of the suits values times 4 plus, what's this interesting? Given spades high, we can now list our deck in order of increasing rank. For card and sorted spades high. What is going on in this function? Hey, how's it going, Matthew Edmonston? How's it going? I'm just reading the Fluent Python book. You can get access to this PDF in my Discord for free down below. We're just reading this book and studying it here. The function spade high appears to be assigning a numerical value to a card based on its suit and rank using the concept of spades high, which means that the suit of spades' value is the highest. So suits dictionary, this dictionary assigns a suit to a specific numerical value, for spades being the highest at 3, clubs being 0 at lowest. The dictionary helps determine the priority of the suit when comparing cards. So rank value of collection. So the rank value, French deck.ranks is assumed to be a list of ranks, 2 all the way up to ace. The index method is used to find the position of the cards ranked in the list, which effectively gives the cards ranked as a number. If the card is K, it would return 11 is the starting from 2. Okay, so it would give its position 11 out of 13. Rank value, return rank value, which would be 11, times 4 for length of suits values, plus suits. This formula combines the rank and suit values. Rank value, which is 11 for king, times length of suits 4, scales the rank value by a factor by the number of possible suits 4. The idea here is that ensures that the rank value comes first in determining the card's overall value. For example, if the card has a rank of 5 and the length of suits is 4, the rank value would be multiplied by 4, making it 20. Plus suit values, card index suit, index card.suit. So suit values, where's suit values? Oh, here. So suit values, index card suit. So if this is a spade, it gets a 3 plus the 40 for the king, or the 20 for this. So it'll be 23. Okay. This adds the value of the suit to the rank based on value. The suit is given a numeric value, spades 3 hearts 2, which then modifies the overall structure. So example, if the card is the queen of spades, rank card.rank equals quote q queen, right? Card.suit is equal to spades. Rank value for the q would be 10 since the rank starts from 2. The length of suit values is 4, so it would be 10 times 4 is 40, plus the value of the suits, which is 3. So it would be 43 for the queen of spades. The function assigns a unique value to each card based on both its rank and suit, with higher values given to cards with higher rank suits and ranks. Purpose. This approach is useful when needing to sort. Okay, because it'll sort the cards from 0 to 52. Or 1 to 52, 0 to 51. Okay. Although French deck implicitly inherits from object, its functionality is not inherited, but comes from leveraging the data model and composition. By implementing the special methods Dunder length and Dunder get item, our French deck behaves like a standard Python sequence, allowing it to benefit from core language features, iteration, slicing, and from the standard library as shown by the examples of using random choice, reversed, and sorted. Thanks to composition, the length and the get item implementations can delegate all the work to a list object self._cards. How about shuffling? As implemented so far, a French deck cannot be shuffled because it is immutable. The cards and their positions cannot be changed except by violating encapsulation and handling the underscore cards attribute. Right, and except by violating encapsulation and handling the underscore cards attribute directly. In link to come, we will fix that by adding a one-line set item method. Right, because this is non-public, we can't access this directly and shuffle the cards, ourselves manually. That violates encapsulation. So we need a method that'll do the shuffle for us, which is going to show us here soon. All right, you guys, this marks the 2-hour mark of the stream. I'm probably going to go ahead and wrap it up here for today. I really, really appreciate you guys joining me so far. I really wanted to continue on today with our reading and get some more going on with our reading. We've really been slacking, over the past few days with our reading as we've been completing the Harvard CS50X 2025 course. We're on week 9 currently, which is Flask. So tomorrow we'll continue with our reading about, I'd say about 30 minutes. We'll probably do about 15 minutes of each book, but one in DSA and Python and then back in Fluent Python. And then we'll spend the rest of the time of the stream doing the week 9 problem set on Flask using for CS50X 2025. So we are currently on how special methods are used. So let me go ahead and quickly put into here how special methods are used. All right. I really want to like on the weekends, you guys. I really want to focus on like working on our projects. It's just hard, working a 9 to 5 job as a chemist and then having to do an additional, 2 or so hours plus of studying and reading after work. It just gets pretty difficult at times. I know we're going to be going for like I said, come June 1st, we're going to start applying for some junior dev positions. So lots to come on the in the works soon. But we got to keep grinding here. We're trying to level up our studying. So I'm going to be continuing going every day, but also I'm going to really try to also, if I have free time, whether it be at lunch, on my at work, or whatnot, just to open the book and continue reading. So I might not be able to. That being said, is what I'm getting at is I might not be able to, read every line for line on stream. I hope you guys are okay with that. If you guys would rather me uh, read the entire books live on stream, that's okay. But I'm totally open to do that. But just to allow myself some more time, like on my lunch breaks and things like that, I might choose to read a few pages and take some notes just to help move this process along because I am trying to kind of expedite this process a little bit here and kind of kick up our studying a bit in terms of so we can meet our goals, hopefully start applying for some positions come in June. Can you read me in camp? What is camp? I'm not sure what you mean there, Russ. Thanks for joining me here. Baseman 14, are you planning on a full career transition? You know, I don't really know. I'm not trying to put too many expectations on it. I'm really trying to roll with the punches. So whatever happens, happens. I'm mainly just trying to, programming just in general really interests me, and I think it would be fun to do at large scale, making products and whatnot. Um, and so, yeah, I'm not sure. The Hitler book. What is that? What the is that KAMPF whatever that is? What is camp? Maybe I should put this off stream. Fight or battle. Hmm. Carlos says, "Hey bro, did you ever finish the book completely? Are you talking about Python Crash Course? I finished all of part one completely. I didn't move on to the projects as I started making my own projects, but I am very interested in maybe going back on my own free time and completing the Python Crash Course projects like the Django one. I'm potentially thinking about um, maybe taking like a Saturday or a Sunday and setting like an entire 8 hour live stream segment to completing all that one of those projects in the back of the Python crash course just in one sitting. So if that's something that you guys are interested in, I'm very interested in doing that as well. So like we can take and plan a Saturday to just sit down for 6 to 8 hours and complete from start to finish one of the Python crash course, one of the 3 projects it has in the back of the book. Hey Alex, how's it going? Are you going to update your notes on GitHub? Notes to GitHub? Yeah, currently my notes are on GitHub for all of the books I'm reading. I haven't pushed these ones yet today because we just started this today. So I'll go ahead and create a repo and upload this to GitHub if you guys would like it as well. Uh, yeah, of course I'll do that for you. But all my other notes are currently updated live. It means my struggle. It's his diary. Oh, gotcha. My struggle. Huh, interesting. The Python crash course. Yeah, exactly, Carlos. Make sure you guys follow along and subscribe to the channel. We've been growing quite rapidly. We're at 1,547 subs, so thank you guys truly for following along. I've uploaded a Python crash course, try it yourself, a walkthrough video today that's only 2 minutes long, so give that a look if you guys are interested as well. Um, we did a lot of reading today. We did some data structures and algorithms reading, learning about open addressing and linear probing versus quadratic probing versus double hashing. And then we finally got cracking on our Fluent Python read here. So we are currently moving on. I'm taking notes live as well as live all the coding examples, writing them out, making comments, really trying to understand and solidify this knowledge. It might seem repetitive and whatnot to just reconvey and copy out all of what is being written in the book, but this actual physical act of us typing this out is what is going to give us that practice and that understanding. And then by coming up with explanations for what's going on line by line in our own terms is also going to help us to be able to learn and grow quickly. So yeah, Alex, I have all my notes in my GitHub as well as in my Discord link down below completely for free. You can access a ton of my notes and resources. I have a complete roadmap of all of my learning so far that I've been doing these past 7-8 months. So you can follow along there, as well as I provide all of the weekly updates for my CS50X course that I'm taking right now through week 9 right now. All right, so we are on page 19. Let me go ahead and just make a note here. We left off on page 19. Go ahead and save that up. And then I'll stay on. How about I stay on for another 20 minutes until about 10 p.m. Okay, let's do that. That sounds good with me. All right, let's quickly open up the small business manager here. Or, hold on, let's see here. Should we try a LeetCode really quick? Is there an easy one we can do? Why does it do this? Why does it do this? Oh, there we go. Should we try a LeetCode really quick? Can we try one? An easy one. This one's got 70. SQL schema. Trees. I don't want to do trees. Remove duplicates from sorted. Climbing stairs. +1. Which one should we do? Happy number. Contains duplicate. Given an integer array of numbers, return true if any value appears at least twice in the array, and return false if every value is distinct. Okay, so this one, we say, let's go scene, set for value in nums. If value, or we'll go if value in scene, return false, else value dot append scene. And then at the end of the loop, we will return true. Oh, it's a set dot add. Int has no attribute add. Oh, shoot, sorry. Scene dot add value. I had it backwards. Dang it. Wing Hong, are you being sarcastic? I got these all wrong. Inverted. If if it contains duplicate, you return true. If it doesn't, you return false. Return at least twice, return false. If any value appears at least twice in the array, return false. If it's seen, return false. Oh, return false if it's distinct, yeah. All right, we'll submit that one. Boom. Wing Hong giving us some sarcasm. I had days long discussion on this one very last week. Yeah, this one was a struggle. I'm not. Oh, you're not. The first naive solution is quick and easy, but the solution to respect space O1 is impossible unless you've seen the solution or spent a long time. Oh, so this isn't the solution then. Because this uses O of n space. Okay. Mm. Hmm. Well, LeetCode test is for real. It doesn't pass. LeetCode passes easy. What do you mean, Wing Hong? Sorry, I'm not following you. We don't even need this else. Right? This doesn't pass on LeetCode? I'm on LeetCode right now. I think you mean it the other way around. I'm on LeetCode right now. So, now what about this? Now, I think I've seen some stuff on this problem before in terms of can we for value in range or in nums start equals start Dang it. Hmm. No, this one doesn't ask for O1 space at all. So we got 2 test cases to pass. So we could use the XOR operator here to cancel out the values cascading downward, right? Yeah, the LeetCode one is harder, I think. Find the duplicate on Nico. Oh, there's almost the exact same question, 287. Hmm. So what's going on here? Is there a debugger tool? No. So if we XOR, if the start does equals to 0, return false, else return true. Identical except space must be O of 1. I got 2 test cases to pass here with this solution. So if we start on 0, if we're on 1, it'll XOR, so it'll be 1, 2, 1, X3, 2. True. Should be expected false is return true. Let me see here. I'm going to take this. Let me open up my Python. Neat. Go practice. Two 17. Pi. Okay, let me take this array. Right. And then dev dupe on array. So let's go ahead and print start. Dupe on nouns. Right. 1304. Turned. So now what if I do 1, 2, 3, 1? Whoops. 1. 1, 2, 0, 1. 287 asks for linear runtime complexity. Oh, this is 217. For O1 space, couldn't you sort? Looking at the follow, it might be. No worries. This is an extra requirement that requires 2 questions. You must solve the problem without modifying the array numbers and only using extra space. Couldn't you use an array 0 to 9 and store the number of times it's used? Well, does making an empty array equal to the size of n? If that in Python that still uses memory, right? Initializing the dynamic array itself creates memory even if it's empty. I think. So if you had just an empty array with equal length to the input array, then and you're just plugging in numbers, yeah. 287 requires no space. So let me look up the XOR operator. The XOR operator is a binary operator that compares 2 bits and returns 1 if the bits are different and 0 if they are the same. It's completely represents by the caret symbol. So 0, 0 returns 0, which 1, 0 results in 1. Right, so if we loop for value and numbers, we take the XOR, that gives us 1. Take the XOR, that gives us 3. So it's greater than. What if I say it's equal to 1 here? It's equal to 1. Still fails that one. Oh, no, it's equal to 1. XOR operator. So same bit results in 0. So 0 x equals, let's say 1. What does that give you? Ooh. Looks like you're trying to use the XOR operator, which is shorthand for performing on a variable assigning the result. Isn't valid because 0 is a literal value, which you can't modify literals like that. This operation would be 1. So then, what if the array is 1, 2, 3, 1? It would look like this. This first element would start with 1. XOR would result in 3. The result with the next element would be 1. 1 XOR 2 is equal to 0, 1 power of 10. Hmm. Are you adding the extra constraint of one space? Yeah, that's what I'm trying to figure out right now, Christian. Appreciate you for joining me and for following along here. Right, we could use the XOR operator, right? We could use the XOR operator to determine if the value we're currently on so if I take this value, 0, that gives us 1 left over. 1 for the start. If I do 1 XOR equals 2, that would make me go 3. This would put me at 0. This would put me back up to 1. So this contains a duplicate. So it's true. Right? Boom. In this case, XOR 0 to 1 would give us 1 back. XOR 1, XOR 2 would give us 3. This would bring us to 0. And this would bring us to 4. Do you have to use the XOR property, Winghong? Am I even close here? Right? So we have this one here. So turning it into a linked list first? Oh boy. Oh boy. By using a linked list. Yeah, I'm doing bit manipulation. I'm not gonna lie. I think I've seen like a little bit of a hint on like on a YouTube short or something regarding this problem. So if you take hold on, let me take this, throw this in here, say, don't show me any code. I feel like I am close, pause, to solving this. Can you point me in the right direction? Very close. It looks like you're trying to determine whether to use the duplicates in using XOR property. There's a slight issue with how you're using it. Think about how XOR works when applied to duplicate numbers. If a number appears twice, the XOR of those two numbers will cancel out. So at the end of your loop, if you're XORing all the elements, the results will give you a non-zero value only if there's an element that doesn't have a duplicate. However, if your current approach, you're using comparison with 0 to decide if there are duplicates instead of trying to consider what the result would be if all the numbers were unique. Considering what the results would be if the numbers were unique and how XOR would behave in that case. Keep in mind that this approach might need a little tweak to account for finding duplicates. Can you think of a way of tracking numbers you've already seen while looping through the list? Pause, LOL. I honestly, I think you're glazing me a little bit too much here. Like I said, I think I remember seeing, like, I distinctly remember seeing, like a YouTube short a few weeks ago regarding a similar problem using the bitwise. Now, the fact that I can remember that, that's probably the crazy part, but I have seen a similar solution brought up by some of those YouTube short guys that do LeetCode. So that at the end of your loop, so at the end of your loop, if you're XORing all the elements. However, in your current approach, you're using a comparison with zero to decide if there are duplicates. If start, so does the final result value have to be greater than or equal to 0 to be not exactly. The final XOR value doesn't directly indicate whether you have a duplicate based on being greater than 0 or not. Instead, what happens is this. XOR. If there are duplicates in the list, the XOR of the duplicate pairs will cancel out. If there are no duplicates, all numbers will cancel out in pairs if they appear twice, or just leave a non-zero value. But it won't necessarily follow that the result must be greater than 0. To solve the problem for detecting duplicates approach, think about how you can compare each number to see if it's seen before. XOR alone may not be the best way to track duplicates unless you're modifying the approach. Hmm. You think I have to return true? Return length, set nums less than length of numbers. Yeah, that's pretty much the same approach that we've done before. I think are returning true. You have to return right before checking start equals 0. No, because then I would return true no matter what at the end of the loop. Hmm. Yeah, I know. I see what your one-liner is. You just are taking the length and the length of numbers. So if you have a duplicate, the set will remove the duplicate, meaning like one less for the length. So if you have 5 numbers in the original length, and then you have a duplicate in the left side, you'll end up having a 4, which is less than 5, which will return true. I get you what your one-liner says. Yeah, it's a cool one-liner. Here, like if you do this, you can just. Ooh. Brr. Non-printable character return. Invalid non-printable character. Hmm. Zanab, I think that there was a few. We had like Christy in here at the beginning when I first started streaming. She would come in quite often. Same with Angela, but they've stopped kind of coming in into the stream. So maybe they've given up on learning, unfortunately. Baseman, your one-liner did not work here. Syntax error, invalid non-printable character on line 4. Huh. We are not allowed to say what a girl is. That's funny. Okay, so I'm not sure how to use this with XOR. My parens are messed up. I copied exactly what you put. I literally copied your what you wrote. Boom. Let's see what it doesn't like. Getting syntax error. Hmm. Hmm. Here's your error, my friend. We've already, for those that are new here, we've already solved the problem here using just a simple for loop and a set, but we're trying to solve it with constant space here. This is not constant space. This is Baseman's attempt here. He wanted us to throw in here. So non-printable character. Let's throw that in. Caused by invisible character, 0 with space. Huh. There we go. Okay, yeah, I think it was just I think I had some weird spacing going on, like you said, Baseman. All right, this one came out at 10 milliseconds, 58.9. 10 milliseconds, 58.9. So they're both used the same. Yeah. Now we're not allowed to modify the list argument. So I had this attempt where we were using XOR, right? The XOR operator, but using the XOR without don't show me code. I am trying to get it in O space by not using a set. Since you're trying to avoid using extra space like I said, here's a hint. You can utilize the properties of XOR, additional space. Now think about how you can use the XOR to track the elements as you iterate over the list. The trick is to modify the array or keep track of elements seen using some other technique. Okay. So we'll do this. Keep track of previously seen values using some sort of other technique. if I were to keep track of scene value. How can you keep track of scene values? Scene values without using another data set compared to the caret? Compared to the less than? What you mean less than? Oh, in your yeah. You just looked at the bit manipulation. Am I even close, Wing Hong? Am I not even close? I'm not sure of a way that we can keep track of scene vowels without using another data struct. But with XOR alone, there's a limitation when it comes to keeping track of individual elements. Here's why. The XOR property is great for canceling out duplicates, but it doesn't inherently provide a way to remember which elements have already been seen. If you tried elements in a list, it would just give you the results based on the cumulative XOR of the elements without distinguishing between duplicates. For O1 space, you would need to modify the data itself, like swapping or marking elements. The general approach involves sorting the array using a modified algorithm like the turquoise and the hair cycle. Hmm. Has two nested loops. All right. Well, that's fine then. We'll leave it as is for our current solution. So this was our submission here. Scene contains duplicate. We create a set for value and numbers. If value in scene, return true. Else, add the value and return false at the end of the loop if you have all the values. We could also easily do it in one simple liner like Baseman14 suggested. Appreciate you so much. Such as return length set numbers less than length of numbers. Now let's see if we can take this. What happens if we do this but not equal? That should also work. Yeah, that'll also work as well. That one was even faster than the less than. 4 milliseconds. Okay, does anyone know why that drastically changes? 10 milliseconds to half the amount of time with a less than or why does take shorter time than the difference between that and is usually minimal, but in some specific cases there's subtle difference in performance. Not equal checks two different values internally. Its operation often works by comparing bits directly. Less than or equal to checks the values less than or equal to another value, which often involves additional comparison logic. If it has to check the first value smaller. Huh. All right, so not equal to is more performant, I guess. Yeah, usually the speed is very variable. Okay. How much variation in time do you get for the exact same solution depends on LeetCode servers. Guess it has to do with math since less math since it has to do with detect any difference. I'm not a disp. Yeah, right. It has to just detect any difference. So if it's just not equal to it, it's just immediate. That's what I was thinking, right? Maybe it's just like less angles it has to check from. But the less than or equal to should be also just a constant true evaluation. So it might just be server, but I don't know. That's interesting. All right, guys. Elite Code today keeps the doctor away. We are officially grinding on here for, really trying onwards to, like I said, as our goal is for January, or not January, June 1st is to start kind of applying for um, some junior developer roles and seeing if we can get a shot at getting our foot in the door at anything. So we're going to really grind up until then with the daily streams like I've been doing, but really kind of more focusing on the actual deeper learning here. So we're going to maybe try to avoid the actual more beginner level courses and start to really grind deeper. Here's what I mean, pause. But we're really gonna like get into reading these books, Fluent Python, DSA, and Python. My goal is to hopefully complete them before that 2 month marker, and then also to dive into some stuff like maybe machine learning also, but like computer architecture and software design, hardware, learning more about actual computers and how we can understand them better and make ourselves a better programmer that way. Click submit a few times. This is where that computer architecture knowledge would come in handy. CPUs are magic. Yeah, exactly. Just exactly as AJ just said. He read my mind. Is I really want to understand, why things are happening. I've always had that curiosity to me is that I've always wanted to know why certain things. Like if you told me to do something, or my parents told me I needed to do something this way, I always ask why. And it's not an act of defiance. It's just a personality trait of curiosity because I wanted to know if I was doing the most efficient or productive way of doing it, and if I could find any improvements to make my life easier. And I've taken that property into my current workflow, and that's how I've kind of been able to get some promotions so far up to like mid-level scientist in only like 3 years. And so since I've started out of college, so anyways, we're really gonna grind here for the June 1st deadline for completing and getting some applications out there. I could really use your guys' help maybe going over resume stuff within the Discord. I'll probably make a resume channel in the Discord so people can post their resumes for feedback. I think that's a great idea someone gave. Also, guys, I'm going to try to my best to do daily uploads for videos. We'll see how long that lasts. I'm going to try to alternate between the condensed stream highlights for the CS50X watch-alongs and the Python crash course try it yourselves. And then maybe we can incorporate some other small, series here and there of as we see fit. But thank you guys so much for joining me this evening. I really, really appreciate all of you. One and all, it's honestly a pleasure to be able to hang out with you guys day in and day out. I have so much fun, and it's really a great time to talk to you guys. And really, you guys, it's really quite it's really quite amazing how far we've come just because we've been able to immerse ourselves fully in this material by talking with you guys for hours on the stream, just by talking about these subjects over and over again. We've been able to really immerse ourselves and grow quite rapidly over these short few months. But thank you guys so much for being here. I will see you guys tomorrow, 7 p.m. PST, where we'll continue on with DSA and Python and Fluent Python, as well as take a shot at the Week 9 CS50X problem set on Flask. So that'll be tomorrow, guys. I'll see you then. Thanks so much for joining me. See you guys then. Bye, guys.